Hello everyone and welcome to Shay's Tech Academy. As we near the end of our beginner-level Python course, it's time to put our knowledge into practice and reinforce the concepts we've learned. Today, we will conclude the course with a series of exercises that cover the topics we have explored throughout our journey. These exercises are designed to challenge your understanding of Python programming and provide hands-on experience. They will require you to apply the concepts we've covered, such as variables, data types, if-else statements, loops, functions, file handling, and exception handling. By solving these exercises, you will gain confidence in your programming skills and solidify your understanding of Python. Each exercise will come with a set of instructions, and it will be your task to write the code and obtain the expected results. I encourage you to tackle these exercises independently, as it will allow you to practice problem solving and develop your critical thinking abilities. Don't worry if you encounter difficulties along the way. Remember, learning happens through overcoming challenges. For each exercise, I will do the exercise with you and explain its solution. The code will be commented to help you understand the logic behind it. Additionally, I will demonstrate the execution of the code to give you a visual representation of the expected results. Now let's dive into the exercises and apply what we've learned throughout this course. Get ready to write some Python code, test your skills, and have fun. Let's begin with the first exercise, which is very basic. Let's write a simple program that prints the phrase, "Welcome to Shay's Tech Academy," to the results or in your console. You can pause the video and try the exercise yourself. When you're done, hit the play button and we'll do it together. Okay, let's do this together. In this exercise, we are using the print function to display our phrase in the console. The print function is a built-in Python function that allows us to output text or values to the console. The print function takes one or more arguments, which can be enclosed in single quotes, double quotes, or triple quotes. In this case, we enclose the text, "Welcome to Shay's Tech Academy," in double quotes to indicate that it is a string of characters. After the print function is called, it displays the provided text as output like this. Let's move to our second exercise now. This exercise will be about arithmetic operations. What we want to do now is to write a program that performs basic arithmetic operations like addition, subtraction, multiplication, and division on two numbers. So get started and pause the video and come back when you are done, and we'll do it together. Right, let's do it together now. So, in this exercise, we are performing basic arithmetic operations, addition, subtraction, multiplication, and division on two numbers. First, we declare two variables, number 1 and number 2, and assign them the values 10 and 5. Then we perform the arithmetic operations and store the results in separate variables. The addition underscore result holds the sum of number 1 and number 2. The subtraction underscore result holds the difference between number 1 and number 2. The multiplication underscore result holds the product of number 1 and number 2, and the division underscore result holds the quotient of number 1 divided by number 2. Finally, we use the print function to display the results. We pass in the strings addition, subtraction, multiplication, and division as the first argument to provide a label for each operation, and then we pass in the corresponding result variables as additional arguments. When we run the program, the console will display the results of the arithmetic operations. The addition of 10 and 5 is 15. The subtraction of 5 from 10 is 5. the multiplication of 10 and 5 is 50, and the division of 10 by 5 is 2.0. Let's now move to our third exercise. This exercise will be about data types and variables. In this exercise, let's write a program that declares variables of different data types like integer, float, and strings and displays their values. The timer starts now. Okay, let's do it together. In this exercise, we are declaring variables of different data types: an integer, a float, and a string. First, we declare the variable integer underscore var and assign it the value 10. The data type of this variable is an integer, which represents whole numbers without decimal points. Next, we declare the variable float underscore var and assign it the value 3.14. The data type of this variable is a float, which represents decimal numbers with a fractional part. Finally, we declare the variable string underscore var and assign it the value hello world. The data type of this variable is a string, which represents a sequence of characters enclosed in quotes. Then we use the print function to display the values of the variables. We pass in a label as the first argument to provide a description for each variable, followed by the corresponding variable name. Now when we run the program, the console will display the values of the variables. The integer underscore var holds the value 10, the float underscore var holds the value 3.14, and the string underscore var holds the value hello world. Data types in Python determine the kind of data a variable can store and the operations that can be performed on that data. Variables serve as containers for holding values, and their data types define the nature of the values stored in them. Understanding data types is essential for writing accurate and efficient code, as it ensures that variables are used appropriately based on the type of data they are meant to store. Let's now move to our fourth exercise. This exercise will be about if-else statements. In this exercise, let's write a program that prompts the user to enter their age and determines if they are eligible to vote based on the entered age. Start your timers. Right, let's get cracking again and do it together. In this exercise, first, we use the input function to prompt the user to enter their age. We convert the input to an integer using the int function and store it in the variable called age. Next, we use an if-else statement to check if the age is greater than or equal to 18. If the condition is true, we print the message, "You are eligible to vote." Otherwise, if the condition is false, we print the message, "You are not eligible to vote yet." Let's run this now and give 25 as the age of the user as an example. As you can see, when the user enters an age of 25, the program determines that they are eligible to vote based on the if-else condition and displays the corresponding message. Let's now move to our fifth exercise. This exercise will be about exception handling. This was the last lesson we did in the course, so I hope you still remember some stuff from that. Let's write a program that prompts the user to enter a number, and it calculates the reciprocal of the number and displays the result. In the same exercise, we also handle potential exceptions that may occur during the execution of the program. You can start now. Okay, let's take a look together now. Here, inside the try block, we use the input function to prompt the user to enter a number. We convert the input to an integer using the int function and store it in the variable numbers. Next, we calculate the reciprocal of the number by dividing 1 by the entered number and store it in the variable reciprocal. We use the print function to display the reciprocal value along with descriptive messages. If a zero division error occurs during the execution of the try block, meaning when the user enters 0 as the input, the program jumps to the corresponding except zero division error block. It prints an error message stating that division by 0 is not possible. Similarly, if a value error occurs, meaning when the user enters a non-numeric value, the program jumps to the except value error block. It prints an error message indicating that the input is invalid and asks the user to enter a valid number. So, let's run this now 3 different ways. First, we will give the proper value, let's say 5. In this case, it will display 0.2 as the reciprocal of 5. Now let's enter 0. Since 0 is not divisible by 0, it will indicate to us that this number cannot be divided by 0. Third and final way to test now. Let's put in a non-numeric character instead of an integer. This will tell us that our input was invalid since it is not a number. Let's now move to our 6th exercise. This exercise will be about for loops. Let's write a program that calculates the sum of all numbers from 1 to a given number. Timer starts now. Okay, let's do this together. In this exercise, we are writing a program that calculates the sum of all numbers from 1 to a given number. For that, we first use the input function to capture user input and convert it to an integer using the int function. This allows us to specify the upper limit for our sum calculation. Next, we initialize a variable sum to store the sum of the numbers. We use a for loop to iterate through a sequence of numbers using the range function. The range function generates a sequence of numbers starting from the first argument and ending at the second argument minus 1. In this case, we start from 1 and go up to number plus 1 to include the given number. Within each iteration of the for loop, we add the current number I to the sum variable using the plus equals shorthand operator, which adds the value on the right-hand side to the variable on the left-hand side and assigns the result back to the variable. After the for loop completes, we have the sum of all the numbers from 1 to the given number stored in the sum variable. Finally, we use the print function to display the sum by passing in the string sum as the first argument and the sum variable as the second argument. So, if we run the program and enter the number 5, the console displays the sum of all the numbers from 1 to 5, which is 15. Let's now move to our 7th exercise. This exercise will be about while loops. Let's write a program that counts down from a given number to 0 using a while loop. Your time starts now. Right, let's do this now. So, here we are writing a program that counts down from a given number to 0 using a while loop. First, we use the input function as usual to prompt the user to enter a number. Again, we convert the entered value to an integer using the int function and assign it to the variable number. Next, we check if the number is positive. If the number is less than 0, we print an error message asking the user to enter a positive number. If the number is positive or 0, we proceed with the countdown. In this case, we use a while loop to iterate as long as the condition number greater than or equals 0 is true. Within each iteration of the while loop, we print the current value of number using the print function. Then we decrement the value of number by 1 using the minus equals shorthand operator. This decreases the value of number by 1 in each iteration. Then the while loop continues until the value of number becomes negative. Once the value of number reaches -1, the condition number greater than or equals to 0 becomes false, and the loop terminates. So now, if we run the program and enter the number 5, the console displays the countdown from 5 to 0. Each number is printed in a new line. And if we enter 0 as the number, the console displays only 0, since the condition number greater than 0 is initially false, and the loop terminates without executing the loop body. Remember one thing. The program includes a check to ensure that the user enters a positive number. If a negative number is entered, it provides an error message and doesn't proceed with the countdown. Let's now move to our 8 exercise. This exercise will be about lists and list manipulations. Let's write a program that creates a list of names and performs various operations on it like accessing elements, adding and removing elements. Your time starts now. Okay, let me drive this now. In this exercise, we are writing a program that creates a list of names and performs various operations on it. We start by creating an empty list called names using square brackets. To add names to the list, we use the append method, which adds an element to the end of the list. In this case, we append the names Alice, Bob, and Charlie to the names list. To access elements in the list, we use their index within square brackets. Indices start from 0, so names square bracket 0 accesses the first name, names square bracket 1 accesses the second name, and names square bracket -1 accesses the last name. We modify an element in the list by assigning a new value to a specific index. In this case, we change the second name from Bob to David by assigning names square bracket 1 equals David. To remove an element from the list, we use the remove method and specify the value to be removed. In this case, we remove the name Charlie using names.removeCharlie. To add multiple names to the list at once, we use the extend method and pass in a list of names. This adds the names to the end of the names list. In this case, we extend the list with the names Eve, Frank, and Grace. Finally, we use the print function to display the updated list of names. So, if we run the program, it displays the first name, second name, and last name in the list, and then prints the updated list of names after performing various operations. This exercise showcases how lists in Python can be used to store collections of elements and perform operations such as accessing elements by index, modifying elements, removing elements, and adding multiple elements. Let's now move to our second last and the 9th exercise. This exercise will be about functions. Let's write a program that defines a function to calculate the area of a rectangle. Your time starts now. Okay, let me have a go at this now. Okay, so first, we define a function called calculate_rectangle_area that takes 2 parameters, length and width. Inside the function, we calculate the area of the rectangle by multiplying the length and width together and store it in the area variable. Finally, we use the return statement to return the calculated area from the function. To obtain the dimensions of the rectangle from the user, we use the input function and convert the entered values to floating point numbers using the float function. We prompt the user to enter the length and width of the rectangle separately. Next, we call the calculate_rectangle_area function and pass in the entered length and width as arguments. We store the returned area in a variable called rectangle_area. Finally, we use the print function to display the calculated area by concatenating the descriptive message with the value of rectangle_area. So, if we run the program, it prompts the user to enter the length and width of the rectangle. Let's enter the value 5 and 3 in this case. The program calculates the area of the rectangle by calling the calculate_rectangle_area function with the provided length and width. The calculated area of 15 is then displayed on the console. In short, the program demonstrates the use of functions to encapsulate a set of instructions and perform a specific task, in this case, calculating the area of a rectangle based on the provided length and width. Let's now move to our last exercise, and we will finish off the course then. This exercise will be about file handling. Let's write a program that reads data from a text file and performs some processing and displays the results. For example, let's have some text in the file, which is lowercase. We will make all the text uppercase and process the same. Your time start now. Okay, this is going to be a bit tricky, but let's start. So, are writing a program that reads data from a text file, performs some processing, and displays the results. First, we open the text file named data.txt using the open function. We pass two arguments to the function: the name of the file and the mode in which we want to open it. In this case, we use R to open the file in read mode. Next, we read the contents of the file using the read method on the file object. The read method reads the entire content of the file and returns it as a string, which we assign to the variable data. After reading the contents of the file, we close the file using the close method. It's important to close the file after reading to free up system resources. We then perform some processing on the data. As I said at the start, we need to convert the data to uppercase. So, to do that, we are using the upper method, which returns a new string with all characters in uppercase. We store the processed data in the variable processed_data. Finally, we use the print function to display the processed data on the console. So, now if we run the program, it reads the content of the data.txt file, performs processing by converting it to uppercase, and displays the processed data on the console. You can see here it converted all the lowercase text that we saw earlier into uppercase. The program demonstrates how to read data from a text file, perform processing on the data, and display the results. You can customize the processing steps based on your requirements. With this, I would now like to say congratulations to everyone that have been part of our course. We are now at the finish line, and you have successfully completed the exercises that conclude our beginner-level Python course. I'm incredibly proud of all the hard work and dedication you've put into learning Python programming. Remember, learning programming is an ongoing journey. As you continue to explore Python and expand your knowledge, don't hesitate to challenge yourself with more complex problems and projects. The more you practice, the more confident and proficient you will become. Please note our next course on Python programming will come out in the next few days. In the next series, we will level up our game and use the knowledge from this series to do much more complex stuff. By joining our channel, you will gain access to valuable resources, including tutorials, coding challenges, project ideas, and informative discussions. I encourage you all to stay tuned and make sure to share the knowledge and experiences you've gained during this course with your friends, colleagues, and anyone who might be interested in learning Python. Don't forget to like, share, and subscribe to our channel. See you all in the next Python programming series.